Welcome to my page, everyone. We have a question before us where we are going to look at it together. So the question is from JAMB 1989 and is actually from Soundwave. And the question says a vibrator of frequency 60 Hz. So let's take note of that. The frequency of the sound traveling is 60 Hz. Is used in generating transverse stationary waves in a long thin wire. If the average distance between successive nodes on the wire is 45 centimeters, find the speed of the transverse waves in the wire. All right, so basically you need to understand some things they mentioned here. We have transverse stationary waves. We also have successive nodes. So transverse stationary waves means that the wave travel between two ends. All right, so how do you draw the traveling of transverse stationary waves? All right, and the pattern which the wave travels, you need to first draw it. And let me use black ink. All right, so we have the traveling waves. The traveling waves is generally this way. All right, it goes up, down. So this is traveling waves, which is called waveform. And I can also draw another one downward. All right, goes up and then downward and then and so on. Now, because this particular wave is transverse stationary wave, so that means at every point there is an end here. There's an end here. All right, there's another end here. All right, there's another end here, and there is another end here. All right, and so on. Now, at every end we have what we call nodes. We have what we call nodes, and so on, like that. Nodes. All right, now the question says between successive nodes. That means between two successive nodes. So we are going to extract two nodes out in this pattern. So it's going to look like this, right? Like what we drew up there. So it's going to look like this. So we have this pattern, and we also have this. So these nodes, and this another node. All right. So the question says the average distance between successive nodes is 45. So the length between these two nodes is 45. It's 45 centimeters. So I'll write L to be 45 centimeter. Right. So cm. All right. So now what we are going to do next is we need to understand that when you have a waveform like I drew the other time, and you have a waveform, let me do that here so that you get it clearly. You have a waveform, and let me complete this like this. All right, now okay, let me also complete this up one this way. Now the distance between from here down to this place, right, is the wavelength. That is when you complete a cycle. When it goes up and down, you have completed a cycle, one cycle. All right, then half of it will be from here to this place will be 1/2 lambda. That is 1/2 of the wavelength. All right, so which means that up here from between here to this place is actually 1/2 lambda. 1/2 lambda. Then means that we can say that the length is equal to 1 over 2 lambda, which is also equal to 45, which is 45 centimeter. All right, sorry, which is 45 centimeter. All right, so now it means we can easily say that 1 over 2 lambda equals to 45 45. All right, then you can say lambda to be equal to 45 times 2, 45 times 2, then that will be equal to 90 centimeter. So you need to convert this centimeter to meter, so you divide it by 100, so that will give us 0 0.9 meter. 0.9 meter. So we need to also recall the formula for velocity of sound, which is v equals to the frequency times the lambda. Frequency times lambda. So v, which is what they are asking us to find, equals to the frequency was given to be 90, so we can see it here. It was 60 hertz rather. It was given to be 60, so we have 60. Sorry. So I have 60. So let me use red. So I have 60 multiplying 0 0.9. All right. So 60 multiplying 0 0.9 will be 54 meter per seconds. All right, so this is how you will solve this question. Right, you need to understand some basic concepts, the waveform, what two successive nodes mean, and then what do we know about transverse stationary waves. So couple of videos that I'll be doing, I'll explain what different types of waves and the application of waves and all that. So this is how you solve this question. Thank you.